I am Dr. Rajiv Mishra from IIT Patna. The topic of today's lecture is ML based predictive maintenance at the IoT edge. In this lecture, we are going to cover the following details listed over here as overview. So, in this overview, we will now briefly talk about the machine learning and IoT, how they goes together. Then the prime objective of this lecture is to introduce the processing of an IoT sensor data with the machine learning, and that specifically at the edge. While we touch many aspects of machine learning workflow in this lecture, but this lecture is not intended as an in-depth understanding or introduction to the machine learning. So, we do not attempt to create highly optimized model for the use cases we use here in our lecture. So, it is just an illustration to represent how the machine learning is used for creating the predictive maintenance process for IoT and at IoT edge. That is the process of creating and using the viable model from machine learning for IoT data processing. So, let us get started with looking at the machine learning development at an IoT edge workflow. So, that starts with the data collection. So, the sensors used to send the data of that particular environment which they are embedded into. That is, they will collect the time series data which is coming from various sources and formats and the rate. So, this is an example where these sensors are embedded into the things. So, these sensor will collect the sensor data. Sensor data is collected, and this particular data is in a particular form, and that is called the time series data, which is coming from different sources, that is from different sensor sources, and often having a different formats and the different rate in which these sensors are sending the data. So, this is called the collection, and this collection has to now communicate through the telemetry or through data ingestion mechanism to the process, and this particular process may run either at the IoT, either at the edge, IoT edge, or at the cloud. The next stage after this processing is doing the pre-processing of this incoming data, and that is to parse, normalize, enrich and transform. So, this particular process is a pre-processing of this sensor data, which is also sometimes called as a time series data. So, sensor or a time series data which sensors used to send will put under the pre-processing stage, that is called the process here, which is shown over here using various tools and techniques which are available at the cloud. The next stage after this pre-processing is the storage. So, this particular storage will be either in the cloud or at the edge to a little size. So, the cloud has enormous level of storage, and it uses various time multi layered time series data store, which is optimized for variety of analysis. So, there are many possible data stores which are being offered as a service by different cloud providers, and the application developer has to choose one of these particular platform. So, once the data is stored, then this particular data will then be explored and put on the monitoring of these things. first of all. Second is it may perform an operational analysis, that means using the dashboard you can see the progress, how the machine is working. Third is using this particular data which is often put in the store, create the model using the machine learning algorithm, and this is called the learning phase. This particular learning model, when they are deployed with and when they will see the new data incoming from the sensor, they will be able to do the prediction. So, this is done in the analysis phase. So, analysis is just to run an ad hoc queries for monitoring the environment or operationalize using asset based analysis or use the machine learning algorithm to train the model, and this trained model often put or deployed in the cloud or at the edge to make the predictions, and these particular predictions are often used to make this business intelligence or the business logic. For business intelligence or business logic. Now, let us go ahead with discussing a little background of the machine learning. Nevertheless, we are not going to discuss everything about the machine learning, only a little background which is good enough to understand this particular topic. So, the machine learning with IoT reference we will talk about. So, starting with some little definitions. So, as you see that this broad area is often called as artificial intelligence. Artificial intelligence is defined as the property of a machines that mimic the human intelligence behavior as characterized by the cognitive ability, memory, learning and decision making. So, that means artificial intelligence will make this computer or the machine mimic the intelligence like human intelligence, and will be specialized in the topics like learning, forecasting, predictions, decision making and other cognitive ability. So, therefore, we can understand this artificial intelligence is a program that can sense, reason, act and adopt, and very well often used in the IoT parlance. Now, this particular artificial intelligence is supported by the machine learning. So, machine learning is a branch of artificial intelligence and a computer science which focuses on the use of the data. So, here we will refer to the IoT data. So, focuses on the use of data and the machine learning algorithm to imitate the way humans learn through the examples and gradually improves the accuracy of learning for making the predictions. So, therefore, the machine learning algorithms whose performance improves as they are exposed to more data over the time. So, this particular aspect, since these IoT sensors are generating a lot of data as the time goes on, more data comes into, therefore, it is a good opportunity to train the machine learning model with a good accuracy at all times. Now, the next part, that is the deep learning. So, deep learning uses the labeled data set, also known as supervised learning, is to inform its algorithm, but it does not necessarily require the labeled data set sometimes. So, deep learning can ingest unstructured data in its raw form, and it automatically determines the set of features which distinguish different categories of the data from one and another, that is called classification. So, the deep in the deep learning is just referring to the number of layers in the neural network. So, non-deep machine learning is more dependent on human intervention and human experts determine the set of features to understand the differences between the data inputs. So, the deep learning is a subset of a machine learning in which multi-layered neural network learn from vast amount of data. So, as you know that the humans also uses neurons and neural network. Clearly here in deep learning it uses artificial neural networks for learning. So, once it sees the data it learns through this artificial neural network. So, as we collect a vast amount of data, therefore learning this model will bring more accuracy or to the predictions. Now, let us see the use of machine learning for predictive maintenance. So, predictive maintenance using simple machine learning algorithm, we can create a simple model of a machine with a normal operating conditions for any application and determine the values that falls outside that normal area. So, for example, if you can train a model for a motor which is capturing the vibration with two sensors, namely A and B, in the normal working conditions. That means that using normal data points the machine has a good understanding what the motor vibration value could be approximately when the motor is operating in a normal mode. Normal mode falls into this particular area. Now, let us say one day at a random point in the time the model observes that the value of sensor A is 8 here. That means it is away from the normal and the value of the sensor B is still 2. So, you can see that this particular value of a sensor B is 2, whereas for sensor A this value becomes 8. So, this particular point which is drawn over here is not the normal operation. So, this is clearly an unusual value. So, the trained model can easily say that this new value is not normal and this is called an anomaly detection. Often it is very easy to do this anomaly detection with the help of machine learning, and this is also one of the way you can do this predictive maintenance, or you can predict when this abnormal behavior will be now coming and showing into that particular operation of the motor. So, this is how the machine learning works to detect an unusual behavior of a machine. So, let us go ahead in talking about more details about the predictive maintenance. So, predictive maintenance has now completed its journey, starting with the reactive maintenance. So, let us introduce the predictive maintenance with the full pipeline, with the full growth to this stage, which is called the predictive maintenance stage, which is the most advanced predictive maintenance for industry 4.0. So, in the past the companies used the reactive maintenance. So, reactive maintenance, when the equipment is down, this is focusing on preparing the assets once the failures have occurred. Now, then this will stop functioning of the machine in the factory environment in the reactive maintenance. Then they thought of improving this downtime than using the preventive maintenance. Preventive maintenance is also called the schedule based or a planned maintenance. So, schedule based or a planned maintenance refers to performing the periodic maintenance based on the manufacturer's recommendation, and the focus was on reducing the failures by replacing the parts based on the worst case lifetime for critical pieces of manufacturing tooling. So, this preventive maintenance is better than reactive in terms of improving the downtime of the machine, but still it is not sufficient to reduce the downtime to a 0. Now, then comes the condition based monitoring or a maintenance. So, here manually inspect with preventive maintenance and replace the parts when showing the sign of the failure. Now, with this explosion of computers and sensors. Now, these companies and IoT, these companies or the industries or manufacturing companies are now engaged in machine learning led the condition based maintenance to reduce this cost while improving the uptime of this particular factory, and there comes the predictive maintenance. So, predictive maintenance takes the condition based maintenance to a further level, and in this methodology machine learning analytics is used to predict the machine's failure early by examining the real time sensor data and detecting the changes in the machine health status. So, it often uses the sensor data, which is nothing but a time series data, and will predict when the machine is going to fail. So, that is why this is called the predictive maintenance. It will do the analytics to find out or to predict the failures of the machine, and therefore, before it fails the maintenance is done, and therefore, there is a very little downtime, and now the companies are improving with the technologies like IoT. So, let us introduce this predictive maintenance in more details. So, predictive maintenance employs the advanced analytics on the machine data which is collected from the end sensor nodes to draw the meaningful insights and more accurate predict the machine failures beforehand. It comprises of 3 steps. One is to sense, the second is to do the computation, and third is to perform an act. Sense, compute and act. Let us understand these 3 different things in more details. So, here the data from the sensors, like here the sensor are embedded into the things. So, we are talking about IoT, that is the sensors embedded in the things, and thus they become the data source. So, these particular sensors will generate the data. So, depending upon the machine types and required the failure analysis, different sensors are used. So, different sensor signals such as the temperature sensor or a sound, magnetic field, current, voltage, ultrasonic, vibration, these sensor data are now analyzed to predict the failures. So, you can see here these sensors often send the data, and then these are often used to do this computation and predict the time to fail. So, the predicted information from the sensor data analysis is used to generate an event, work order and notification. So, the sensor data is also used to visualize the machine's overall operating conditions. So, that is an action. So, action is taken when the event reports an anomaly, a machine that is nearing the end of its useful life, or when wear and tear is detected in the machine part. Therefore, what we have told you here about the introduction of a preventive maintenance is that the sensors will monitor the machines, its parameters such as temperature, sound, magnetic field, current, voltage, ultrasonic, vibrations, etc., and send this particular data for performing the computations. So, this particular sensor data is often used to visualize the machine's overall operating conditions. So, the action is taken when the event reports an anomaly, a machine is then nearing the end of its useful life. Predictive maintenance problems. So, let us see what are the issues which are addressed in the predictive maintenance. Will this equipment fail in a given period of time? What is the remaining useful life or a time of failure of a machine? How to quantify the wear and tear of expendable components? So, this is a subset of remaining useful life and focuses on the shorter living subsystems. For detecting anomalies in equipment behavior with further analysis, it can improve the failure classification and also optimize the equipment setting. So, let us see the machine learning workflow in the predictive maintenance. There are 6 steps, is we have already some of them we have told. The first is to define, is that clearly define the problem and intended goals, then you decide how to tackle this particular problem. Second step is to prepare. The essential thing here in the predictive maintenance under preparation is to prepare and clean your data, that is pre-processing. Depending upon the time series, the observations may be a daily, weekly, monthly, quarterly or yearly, which require to be classified and prepared in this time series data. Third is to analyze, that is now your data has been prepared, you can start doing the analysis. Time series data can be decomposed into the several components, including the trend and seasonality. Fourth is the model. So, model is to predict using the insight from the analysis. So, therefore, the step 4 of this generating or training the model is to combine the trend and seasonality to create a forecast. Refine the weightings of each component to produce an accurate model. If needed, edit the forecast to account for any special factors like sale and so on. Fifth factor is about deploy. So, once you have a good model, it is the time to deploy it and make the forecast live. This may take the form of a performance dashboard, a report or a web. Now, finally, the stage of the preventive predictive maintenance is called monitor. So, once the forecast is live, make sure that monitor its performance. This might involve updating the forecast as the new data comes and available and calculates its accuracy. For example, MAPE, that is mean absolute percentage error. So, with this, let us go ahead talking about the machine learning workflow, and we will see about the different aspects. So, as we have already stated that in the machine learning workflow, the important or the first step is to clearly define the problem. What are you going to solve with the help of machine learning prediction models? So, this will create the predictive and the intended goals and the outcomes. After that, you can decide how to tackle the task at hand, and then you can use the different tools for data preparation and then use this for analysis and modeling for the deployment purpose. Now, in the prepare stage, that is the data preparation or a pre-processing, the data, it is essentially to properly prepare and clean the data that will be used to train the model. With good accuracy, and then use it for making the predictions. So, this is very essential step of cleaning or preparing the data set, so that the machine learning model can be trained with a good accuracy and it will be put for the its predictions. The next step is here into the data preparation is to data cleansing, might involve removing some of the duplicate or noise or inaccurate and dealing with the missing data or sometimes the outlier data to make this data making it work with training the model accurately. So, in case of predictive maintenance, the data will be in the form of a time series data. So, all this preparation has to happen with the time series data. Now, depending upon what is being predicted, the observations might be categorized into daily, weekly, monthly, quarterly and yearly intervals. Now, machine learning workflow in the analysis part, once the data has been prepared, the next is to analyze. Now, here for time series data, this involves decomposing the series into the constituent part and they include the trend and seasonal effects. So, trend is a long term overall pattern of the data and is not necessarily linear. Seasonality is a recurring pattern of a fixed length which is caused by seasonal factors. So, these two things are very important in the analysis. Modeling or the training the machine learning model is called modeling. Now, to make the predictions when the model is created by combining trend and seasonality components, you are having various softwares, and these particular softwares will now manually refine the models to have this more accurate model. So, different performance metrics we will see about that, how to judge the accuracy of the model. So, models can be edited to account for any special factors. However, careful introducing the biases into the predictions make it less accurate. So, we have to now be careful while deciding about the model. Now, the next stage is called deploy the machine learning. Once the model is working right and acceptable accuracy, then it can be deployed and make it live for making the predictions in the real time. This means that the decision makers with the business logic can utilize and benefit out of these particular predictions. Sometimes a visualization may also be helpful, and it will be done through the performance dashboards or graphic or a table or a report or a web application. So, you may also include the prediction intervals as we have stated in the previous slide, and expected this particular limits is expected in the future values to fall within between if the model is correct. So, monitor is the next step in the machine learning models. Once the prediction goes live, it is important to monitor its performance, and therefore, various accuracies and error mechanisms are there to monitor the model performance. So, the popular measures are mean absolute percentage error and the mean absolute deviation. We are going to look into these aspects more clearly. So, data scientists, they are specializing in this kind of technology. So, using error they will be able to monitor the performance of the model. So, therefore, machine learning methods for predictive maintenance from the machine learning point of view, they are going to solve two different problems. One is called classification, the other is called regression problem to solve this predictive maintenance. So, classification means will it fail or not. So, it will classify into two classes, sometimes multi-class classification, also will it fail for a particular region X. This is all classification where yes or no or multiple classes are there, that is called a classification in the predictive maintenance. Regression aspects or a regression problem in the predictive maintenance is about after how long that machine or the failure will happen. So, this will be a predicted value, not the class. So, classification has to predict about the class, where the regression has to predict about a value. Now, to do this classification and regression related problems in predictive maintenance, you require different traditional machine learning approaches such as decision tree, random forest, gradient boosting trees, isolated forest, support vector machines are some of the traditional machine learning algorithms. Similarly, for deep learning, different approaches are there, that is called convolutional neural network CNN or multi-layer perceptrons MLPs, recurrent neural networks and LSTM, long short term memory, and GRUs, that is gated recurrent unit. Now, there are a hybrid of deep learning and a physics based modeling. So, you can use the physics based modeling to generate the training data set where the data is lacking. Similarly, you can also physics based modeling to reduce the problem space, that is you can use for feature engineering you can use physics based modeling to inform and validate different deep learning models and so on. So, we have now covered the entire predictive maintenance from the machine learning aspect. So, let us go ahead and understanding so called deep learning methods, which is very much needed in the predictive maintenance. So, deep learning has proven to show superior performance in certain domains such as object recognition and image classification. Nevertheless, using time series data also it has shown a very improved models and often very popular in the in the time series data analysis also. Now, predictive maintenance is also a domain where data is collected over the time to monitor the state of the assets with the goal of finding pattern to predict the failures. For this, you know that the deep learning algorithms are very powerful and capable to function this kind of problems in the predictive maintenance. So, for among the deep learning, the popular models to do this time series predictions are long short term memory, that is LSTM networks, or the deep learning models which especially appeal to the predictive maintenance due to the fact they are very good in learning from the sequences, and time series data is nothing but a sequence of data over the time. So, this fact lends itself to their application using the time series data by making it possible to look back for a longer period of time to detect the failures. So, therefore, this LSTM allows you to monitor over a longer period of time to detect the failure patterns, and therefore, by detecting the anomalies over the period of observations. Now, the deep learning method another is called multi-layer perceptrons. So, there the neural networks like multi-layer perceptrons provide the capabilities which are offered by the few algorithms such as robust to the noise, non-linear, multivariate inputs, multi-step forecast. Now, the next model into the deep learning is called convolutional neural networks. CNNs are a type of neural networks. They are designed efficiently to handle the image data. The ability of CNN to learn automatically extract the feature from the raw input data, that is in the form of images, can be applied to the time series forecasting problems as well. So, that means a series of observation can be treated as one dimensional image that CNN model can read and distill the most salient elements. So, the feature learning is an automatic identification, extraction, distillation of salient features from the raw input data that pertain directly to the prediction problems that is being modeled. So, CNN gets benefit out of multi-layer perceptrons for the time series forecasting, namely the support for multivariate input, multivariate output, and learning arbitrary but complex function relations, but do not require the model learn directly from the lag observations. The model can learn the representation from the large input and sequence that is most relevant in the production problem. So, now let us see the next deep learning model, that is long short term memory network, that is LSTM networks. So, LSTM networks, usually called LSTMs, are a special kind of recurrent neural networks RNNs that is capable of long term dependencies. So, they were introduced by Hochreiter and Schemong-Buer in 1997, and they were refined and popularized by different researchers. LSTM add explicit handling of the order between observations when learning a mapping function from the input to the output, not offered by multi-layer perceptrons and CNNs. They are the type of neural networks that add native support for input comprised of sequence of observations. So, native support for the sequences is the advantage of this recurrent neural network, and these capabilities of LSTM can be used to a great effect in the complex problems such as neural networks, where the models learn the complex interrelationship problems. So, learned temporal dependence So, the most relevant context of input observation to the expected output is learned and can change dynamically. Now, deep learning methods, that is long short term memory LSTM, the method both learn a mapping from inputs to the outputs and learn what context from the input sequence is useful for the mapping and can dynamically change the context as needed. So, in this particular slide we are now going in details of explaining the architecture or intricacies of long short term networks, that is LSTM networks. So, LSTM networks are designed to avoid the long term dependency problem which happened in the recurrent neural network. So, that means it is capable to sustain or to work with the long term dependency problems which was the drawback of recurrent neural networks. That is, remembering the information for a long period of time is practically the default behavior of LSTM. Now, recurrent neural networks have the form of a chain of repeating the modules of a neural network. In the standard neural network, recurrent neural network, this repeating modules will have very simple structure such as a single 10H layer. So, this is recurrent neural network which is an unfolded form. Rather, you can think of this is the input and this is the neurons and then it will feed back. So, this is unfolded way of showing this. So, this structure of a neuron is shown over here. So, it will be using the previous input, the output of a previous cell as the input. So, that is also called feedback. So, this particular previous input or output of the previous cell is also used here in calculating, and also the input together applied the tan H, and this particular tan H will become the output of this particular cell, and also it will give the input to the next cell and so on. So, you can see that in this way it will be having the short term dependency because it knows what has happened in the previous time step, but it is not able to memorize the long term dependencies over several period of instances. So, that is the drawback of RNN. So, LSTM also will have this kind of chain like structure, but repeating the module has a different structure. So, this particular repeating modules will have, instead of the single neural network layer, it has 4 interacting in a very special manner. So, you can see here, instead of only one tan H, it has a population, it has a different 4 different interacting. This is first, this is second, this is third, and this is 4. So, there are 4 different interacting neurons here in a particular cell. This is called a cell of an LSTM network. So, in the below diagram, so each line carries the entire vector from the output of one node to the input of the other. So, this you can see that this is the input line to the cell, this is input to the cell, keeps on coming in a form of a streams or a flow, and then you can see here there are 4 different vector operations are being performed. So, these pink circles represents the point operation, like this is the vector addition, this is the vector addition, and this is the vector multiplication. while the yellow box here which is shown, while the yellow boxes are learned neural network layers. So, these are the learned neural network layers, their functionalities we will explain later. So, these lines are merging, they denote concatenation, while the line forking denote its content being copied. Here is copied and the copies goes to different locations. So, LSTM cell has 3 gates to protect and control the cell state. So, this you can see over here. The first part is called the forget gate. This is called the forget. The second part is called the input gate and the last one is called the output gate. So, forget gate is the first step of LSTM is to decide what information you are going to throw away from the cell. This decision is made by this sigmoid layer. So, sigmoid layer is also called the forget gate layer. So, it looks at the previous cell output, that is ht minus 1 in the previous time, and xt means the current input, and outputs a number between 0 and 1 for each number in the cell state CTI. So, 1 means completely keep this and 0 means completely get rid of this. So, that means if 0 is enabled, then it will completely forget gate. So, input gate is the next step is to decide what new information you are going to store in the cell state. This has 2 parts. First is that sigmoid layer called the input gate layer. This decide which values will be updated. The next is tan H layer creates a vector of a new candidate values C hat T. This could be added to the state. In the next state we will combine these two to create an update to the state. Deep learning models, long short term memory networks, LSTM networks. It is now time to update the old cell, that is C of Ti minus 1 into the new cell state, that is CT. The previous steps already being decided what to do. So, we need to actually do in this the multiply the old state by Ft, that is forgetting the things we decide to forget earlier, then we add It into C hat T. This is the new candidate values scaled up by how much we decide to update each state values. Now, the output gate of LSTM. Finally, we need to decide what we are going to output in out of the cell. So, this output will be based on our cell state, but will be filtered version. First, we run the sigmoid layer which decide what parts of the cell state we are going to output. Then we put the cell state through this tan H to push the values between -1 and 1. So, tan H now push the values between -1 to 1, whereas sigmoid is between 0 and 1. And to multiply the output of the sigmoid gate, so that the only output parts we decided will be used up. Now, let us see the model performance. So, we have seen the LSTM and we have also covered RNN, but now we will see that once the model is trained with the time series data using the deep learning model, that is LSTM. Now, how are we going to check the performance, that is the part of a data science. So, there are various performance metric, and this is very useful to understand whether your model is good enough to be deployed or still require more data for training. So, the stationary R squared is used in the time series forecasting as a measure that compares the stationary part of the model to a simple mean model. So, this R squared is defined as 1 minus stationary, that is the sum of square residuals from expected values and SS total, that is the sum of squared deviations from the dependent variables sample mean. So, it denotes the proportion of dependent variables variance. A high R squared value shows the model's variance is similar to that true values, whereas the low R square values suggest that two values are not too strong related. Next performance metric is called mean absolute error, that is called MAE. MAE is defined as the average of the absolute difference between the forecasted and the true values. So, where yi is the expected value, so this is the predicted value you can say, and xi is the actual value. Now, the letter n shows the total number of values in the test set, and this is called, and we have to take the absolute of it, and this is the mean absolute error. So, the error in the prediction with the actual values, its absolute is averaged over that particular number of test set, that becomes mean absolute error. Mean absolute error shows how much inaccuracy we expect from the forecast or the average. If mean absolute error is 0, means that anticipated values are very correct and the error statistics are in the original units. The lower MAE values, the better the model is, and the value 0 indicates that it is error free. So, the model with the lower MAE is superior when compared to many other models. So, this is also a very good performance metric to see the performance of that particular model which is trained, how that is all working. Now, the next performance metric is called mean absolute percentage error, MAPE. So, here MAPE is the proportion of the average absolute difference between the projected and the true value, and is divided by the true values. So, here you can see that there is a difference and its percentage is taken, called mean absolute percentage error. Now, the next very important performance metric is called mean squared error, MSE, is an average of error squares. So, here you can see that this is the predicted value and this is the absolute value, and the squared, and its mean is taken up, evaluates the quality of forecasting model or predictor. So, MSE takes into account the variance and bias. So, this MSE is almost always positive and lower values are preferred, and this measure penalizes the large errors or outliers more than the minor errors. Another performance metric is called root mean squared error, RMSE. This measure is defined as the square root of mean square error and an extension of MSE. So, here this, if you compare this RMSE number is in the same unit as the projected value, which is an advantage of this particular method. We will see all these later. So, let us go ahead with a use case for predictive maintenance, that is prognostics and health management. So, objective of this use case is to build LSTM model that can predict the number of remaining operational cycles before the failure from the test data set, that is the number of operational cycles after the last cycle that engine will continue to operate. So, this is a simple aircraft engine, and this is the simple diagram, and we will see that the sensors are placed to monitor the fan combustion, and there are different, so many sensors are there here to monitor this particular working of this engine to operate, and also provided a vector of the true remaining useful life useful life, that is values from the test data set. So, the data set which was generated is called CMAPS and its commercial version is called MAPS dataset, modular aero propulsion system simulation. So, this software provides the flexible turbofan engine simulation environment to conveniently simulate the health, control and engine parameters. So, by looking up this prognostic and health management and for the predictive maintenance using the remaining useful life, you can also as well apply in any of the machines in the industry. So, therefore, this particular use case is very important because it uses the IoT sensor data to monitor this predictive maintenance. So, the simulated aircraft sensor values is used to predict two scenarios. One is the regression model, the other is called binary classification. So, regression model will answer the questions like, given these aircraft engine operation and the failure event history, can we predict when an in service engine will fail. Whereas, so that means it requires the time, how many cycles are still it has to now execute before that engine will fail. This is a regression model. Similarly, the binary classification problem here in this domain will be that is the engine going to fail within W1 cycles or not. So, let us define more details into the data set. So, the data set consists of multivariate time series data. Why? Because so many sensors are needed to monitor the fan, combustor and various component nozzle of aircraft engine. So, therefore, such data set is divided into the training and test data set. Now, each time series data is from different engine. So, engine is operating normally at the start of each time series data and develops a fault at some point during the time series, all is captured into the data set. Now, in the training data set, the fault grows in the magnitude until the system failure. In the test data set, the time series ends sometime prior to the system failure. So, this particular data set is publicly available, that is popularly known as the NASA Turbofan data set. So, aircraft gas turbine and data set contains the time series cycle for all the measurements of 100 different engines. So, let us use this LSTM model for data ingestion. So, we ingest the training, test and the ground data set. So, the training model consists of multiple multivariate time series. So, here in this particular use case, we see that the multivariate time series with cycles as the time unit. So, cycles we are consider as the time unit, together with there are 21 sensor readings for each cycle. So, each time series data can be assumed being generated from different engine of the same type. So, the testing data has the same data set as the training data set. So, the only difference is that data does not include when the failure occurs, and finally, this particular data set is shown over here. So, you can see that these are different sensors S1, S2 and so on. There are 21 sensors which are giving these readings at, and these sensors, sensor nodes are having these IDs, and the cycle is also the time unit. We are now cycle 1, 2, 3, 4 time unit and different settings is also shown over here in the data set. So, once the data set is available, then the next part is to prepare the data and do the feature engineering. So, we have to generate the label for the training data set, which are remaining useful life label 1 and label 2, that is RUL label 1 and label 2. So, this is what is called the labeling. So, this is added while data is to be prepared. Now, each row can be used as the model training sample, where SK columns are the features. So, you can see these are the features and the remaining useful life is the model target. So, these are the target labels. So, the rows are treated as the independent observations and the measurement trends from the previous cycles are ignored. So, this particular features are now normalized using principal component analysis. So, for LSTM model we have to opt for more advanced feature engineering, because this particular earlier feature engineering is good enough for simpler model, because in the machine learning you have to do the feature engineering and like support vector machine can be used for that data set. Now, if you want to use LSTM model and you have to opt for advanced feature engineering, you have to choose the appropriate trend from the previous cycles. So, in this case the training sample consists of the measurements at cycle I, that is I minus 5, I minus 10, 20, 30 and 40 cycles. So, the model input is 3D tensor with a shape n as 6, 24 and so on. N is the number of training samples, 6 is the number of cycles, 24 is the number of principal component features and so on. So, let us see the model. So, LSTM in the time series domain, one important parameter here is the sequence length. So, this may be viewed similar to the picking the window length, that is of 5 cycles earlier, and calculate the rolling features which are rolling means and rolling standard deviation for 21 sensor values. The idea of using LSTM is to let the model extract the abstract features out of the sequence of sensor data. So, here you can see that an example of a sensor values of a 50 cycles prior to the failure of the engine is shown over here, and while feeding this LSTM network, this type of data for each time step and the engine ID is shown. So, let us see this LSTM network. For doing this LSTM network modeling, what is the network configuration? LSTM network will consist of the first layer of 100 units, and then it will be added a dropout layer to control the overfitting. Final layer is the dense output layer with a single unit with the activation, sigmoid activation and a binary classifier and a linear activation and regression problem. So, this is what we have now shown, that if you evaluate these model, what you will get is the different values of these errors, that is mean absolute error and the coefficient R squared error, all these errors are shown over here as the model. So, let us summarize the lecture. So, we have understood in this particular lecture about the predictive maintenance, the machine learning models for predictive maintenance, use case of predictive maintenance using LSTM model, and also we have seen the time series analysis inside. Thank you.